For the last few months I've been making up these precision clock kits, and for some bizarre reason I'm still doing everything myself. One of the tedious parts is that each kit has 6 nuts and 6 bolts, which have to be counted out by hand. This is a solved problem. You can buy commercial screw counters, but they're quite big machines and they cost a lot of money. So I looked into hobbyist screw counters, and a few people have done some nice projects. A few designs use a rotating disc with a dog bone cutout and a digital circuit that counts the screws that drop through. I also found more than one DIY project that built a vibratory bowl feeder. That's the kind of thing you see on How It's Made, where you chuck a load of screws in and they climb up a spiral slope outwards. Those work through giving a very specific rotating impulse, which is done through angled springs and a powerful solenoid. It's really cool, and no doubt quite fiddly to set up. I get the feeling that even if I were to copy one of these DIY projects exactly, it would still take me several days to get a usable result, by which time I probably could have counted out a few thousand sets. And the thing is, the scale I'm working at, I'm making a batch of, say, 50 or 100 kits, so it doesn't take that long to count out by hand. It just feels like there should be a better way, something between the fully automatic screw counter and doing it all manually. Something that could just assist, and ideally something so simple that we can design and build it fast enough that it actually saves us time. Here's the first thing I came up with. It's laser cut 3mm acrylic, pegged together with PLA filament. Nuts go in here. And then you just shake it a bit, pull the trigger. Given how quickly I came up with that, I am very pleased with that. I mean, it's already saved me as much time as it took to design. Obviously, in retrospect, should have given it a much bigger hopper, but I didn't want to commit too much material to the idea before testing it. This distance to get exactly 6, I was off by a bit on my first attempt, but this is why I love laser cutting. Instead of shimming it, I just adjusted the design and cut it again. It takes 30 seconds. Iterating on a laser cut prototype is so fast compared to 3D printing. Anyway, this nut counter is an easy win. Could I do the same thing for the screws? If I just put a slot along the bottom, would they fall into it? And would it work the same way? Well, it's easy enough to test, isn't it? Here's my Mark I screw counter. I added the slot and then just glued on some scraps to make the hopper a bit taller. My concern was that the release mechanism was going to need to be quite complicated. I've just added a lip that shifts over. I was assuming I would need to do some kind of dual action thing, like it would shift the bolts over, then release them, or maybe it shifts them over, they slide into another chamber and are released when you let go of the trigger. But actually this basic mechanism works fine. There's your 6 M3 bolts. So the trigger mechanism works beautifully. It's extremely reliable. The problem is the hopper is way too small, right? If you just chuck a few screws in, it works fine. But if you pour in like 100 screws into there, then it jams because they need to have enough room to wiggle as you shake it and fall into the slot. So I tried putting a lid on it and just like shaking it a lot, but well, it works, but you have to shake it for several seconds, and then if it takes several seconds for each set, then we're not really saving much time over counting them individually, I mean. I mean, we could potentially use this just by repeatedly dropping in a pinch of screws as we go, but with that I feel there's a high risk of spilling them and then just messing up the batch. Once they're in the slot, it works perfectly. So maybe we could just extend that slot and store more between each refill. The first thing I did was chop the design here and make a kind of connector so that we can try out different hoppers and different magazines. To hold enough screws for 25 sets, we'd need about 70 centimeters of slot, which is going to make this pretty unwieldy. So we either need to fold it back on itself or coil it up somehow. I made some test tracks, and yeah, they seem to go around gentle curves just fine. So maybe we can make a few of these tracks and stick them together like Lego. Incidentally, this technique of sticking together acrylic with PLA filament works really well. I think I invented it, at least I've not seen anybody else doing it. It's really easy to do, and it costs nothing. You know, a few holes, and offcuts of 3D printer filament are free. Laser cut holes are always slightly conical, so it's easy to start inserting, but then ends up being quite a tight press fit. It's very fast, it's very secure, and it's easy enough to pull apart if you need to. Right, so here's the Mark II screw counter, and while it is a bit of a handful, it's certainly better than having the hopper on the end of a really long stick. We start by loading up screws into the hopper. And when we've got enough loaded up, just pull the trigger to dispense 6 at a time. If I'm honest, this is perfectly adequate. My main complaint is that it doesn't hold as many screws as I'd hoped. I was hoping for enough to hold 25 sets, which this distance should be, but once it's filled to about here, as you're loading it, they start to fall back along the track. So it starts to become awkward, and it's easier to just half fill it, dispense that many, and then half fill it again. Still, I used this to prepare a batch, and it genuinely saved me time. So from a time-saving point of view, I don't think the incremental benefit of doing another revision is justified. But we're having fun now, so let's do it anyway. Here's my Screw 6-shooter Mark III. It's a long stick, but with an S shape to it to make it more manageable. Holds about 100 screws, which is enough for 16 sets. So it's got parity with the previous version, but it is much easier to load. The angle and turn radius were drawn parametrically, so I could tweak it if it didn't flow properly, but this first attempt seems fine. In fact, the size and shape were mainly dictated by what bits of scrap acrylic I still had left. It's not escaped my notice that there's a fine line between an automatic screw dispenser and a marble machine. In fact, this makes a pretty good fidget device. With it just on the desk, I find myself loading up screws and then dispensing them just as a fiddling activity, because it's kind of fun. Is this good enough? Yes. Could it be improved? Also yes. But what I'm thinking now is, could we apply this same technique to other parts in the kit? The through-mount LEDs would probably work. They're a similar enough size and shape to the bolts, although it's probably more likely to jam because sometimes they arrive with the legs bent. The other parts in the kit, well, there's mostly only 1 or 2 of them per kit, so it doesn't make that much sense to have a dispenser. But the dream would be to have a hopper for every single part in the kit, and just one big trigger that, when you pull, dispenses the entire kit into a bag. For now, I'll share the design files for these on my website. I'll put the link in the description. Though unless you're looking to dispense exactly 6 M3 button head bolts, you'll need to alter it slightly. I suppose if you wanted, say, 20 bolts, you could make it dispense 5 and pull the trigger 4 times or something. I'm really trying to stop myself from making yet another iteration, but I think there's promise in this semi-automatic screw dispensing idea. So if anyone wants to experiment with better hoppers, please go right ahead.